Good morning, everyone, and welcome to the Tejano Virtual Events Happy Math Hour, your weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carrizales, and Albert Isasi. This session will be recorded so that you may come back to it at a later time, and also for those who may have missed today's presentation, may be able to watch it at a more convenient time. Thank you. So now at this time, please mute your mics for the best sound experience. We don't want any of the feedback interfering with today's important lesson. Without further ado, here is Yvette Chuca and Mr. Ruben Carrizales.
Hello, everyone. Happy Friday. So they just posted the link to Math 1324 for those of you who are enrolled in that class. And in this room, we're going to be talking about exponential and logarithmic equations, which is section 3.4 in your Math 1314 class, which is the last section right before your exam 3. So some of you will be taking exam 3 next week. And so we'll get started at any time. If you have any questions, please let me know. And then also if you need to, if you can see my mouse here, if you need to zoom in on the presentation, there's a magnifying glass with the plus sign there. You can make it bigger for yourself. And on the right side, you should see an arrow with a box with an arrow pointing down. You can use that to download the presentation as well. So we'll get started. So here we have log base 5 of 125, and that's equal to x. So for all of these problems, our goal is going to be to solve for x. So if you want to solve for x, then one of the things that we can do is we can look at the problem. And right now it's written as a logarithmic expression or equation. So what we can do is one way to solve for x is to rewrite it as an exponential equation. So in this example, our base is 5. And so we can write our base. And then the log is always equal to the exponent. So since this log is equal to x, then x is going to be our exponent. At this point, there's different ways that you can solve this. One of the easiest ways would be to see if we can apply the one-to-one property. And the one-to-one property can be applied if the base in this left side is the same as the base on the right side. So just by looking at it, they're not the same. But notice that 125 can be written as 5 cubed. Now the bases are the same. And so the one-to-one property allows us to set the exponents equal to each other. So we would get x is equal to 3. And that would be our solution. Now anytime, so let me go ahead and go to the next example. Let's try this one. Now we come back to the previous example. Another way you could have solved this is if you look at the base 5, you can ask yourself, what exponent does 5 have to be to give me 125? And in this example, it lends itself for us to do that. So we can see that 5 cubed would give us 125, and that was our answer. Now over here, if we try to do the same, what power does 2 have to be to give me 25? Then we're not going to find that exponent. And so here it would be more convenient to change to exponential equation. So your base is 2. The log is equal to x. So that means that x is going to be your exponent. And then we have 25. Now at this point, the 25, we cannot rewrite it so that it has a base of 2. And so what we can do is we're going to use a calculator, but we're also going to use a different properties to help us solve this equation. Okay, so let's talk about calculators first. So I have 2 calculators. One is a graphing calculator, and then the other one's just a scientific Casio calculator. In these calculators here, your log key is on the left side for the graphing one, but the problem with the graphing calculator is that the only base that you can use is going to be base 10 or base e for the natural logarithm. And so the problem that we had over here, we cannot use the calculator or the graphing one for that um, using the log key. On the right side, your scientific calculator, if you press the log key, it allows you to put the base and the number. So then we can actually use this calculator for any base. Now, I'm not saying to go buy a scientific calculator, because even your graphing calculator, you'll be able to do any problem. Okay, so and the way we're going to do that is using something called the change of base. So the change of base will allow us to change our problem into a base 10 or a base e, and we want them to be in base 10 or base e so that we can use the calculator. So if you had log of a and then x, then we can rewrite that as log x divided by log a, or we can use natural log x divided by natural log a. So the way it works, it says here, evaluate the logarithm using the change of base formula, and then we're going to round our answer to 3 decimal places. So we have log 3 of 11. So again, with the graphing calculator, we cannot put this question into the calculator, but we can use the change of base. So log 3 of 11 is going to become log 11 divided by log 3. Now notice this log does not have a little number like the 3 over here. When you don't see a little number, that means that it's in base 10. So now we can enter it into our calculator. Make sure you use parentheses. So we have log 11 divided by log 3, and that comes out to 2.1826. But we want to round to 3 decimals, so that becomes 2.183. Okay, so let's look at the next one. So here we have our base is pi, so there's no way we can use our calculator to enter that. So we're going to need to use logarithms, or you can use natural logs. So we're going to have log of 0.5 divided by log of pi, and notice my curly equal sign here. This means approximate. And so if I put that in our calculator, it comes out to approximately 0.606. Okay. So in the previous sessions, we looked at different properties. So we had the product property, quotient property, par property, and then we had these properties. The ones that we're going to use quite a bit are number 3 and 4 down here. And we'll go ahead and look at those in a little bit. Okay. So it says use the properties of logarithms to write the logarithm in terms of log with base 5 of 2 and log base 5 of 3. And so here, what we're gonna get is we can use the product rule. So we have log 5 of 6, and the 6 can be broken down as 2 times 3. And since we're multiplying, the product rule tells us that we can separate it as addition. And so we're gonna end up with log base 5 of 2 plus log base 5 of 3. Okay, so now let's look at this one. It says find the exact value of the logarithmic expression without using the calculator. So in this chapter, if you see any square roots, cube roots, one of the things we can do with those is write them as a power. And so for the cube root, we can write it as 1/3. If you had a square root, it would be 1/2, and so on. So the index is going to be in your denominator here. Now, if we look at this, notice that the base is 4. And when I wrote this as a power here, my base is still a 4 here. Since the base is the same, then we can find our answer using one of the other properties. But I guess I'll apply the power rule here first. So the power rule tells you that this exponent you can bring to the front. So we have 1/3 log of 4/4. So now the 4/4 here is going to help us to use this property, number 3. And our answer is just going to be 1. So since it's 4 and 4, the answer is going to be 1 times 1/3. Our answer becomes 1/3. Okay. So that was using property number 3. Notice that the bases are the same, A, and your answer would have been X. So even at this point up here, since you have a base 4 and 4, the answer is going to be the exponent, which is 1/3. Okay, let's look at a few more. So here I can rewrite my fourth root as a power. So I have e cubed to the raised to the 1/4. And I can simplify. So if I have e cubed raised to the 1/4, I multiply those exponents. So I get e to the 3/4. Now I apply the power rule, which tells me to take the exponent to the front. And so I have 3/4 natural log of e. And notice that natural log of e just means log of e, base e of e. And since the bases are the same, then that's also going to give us the same answer, which is the exponent of 1. And so our answer would be 3/4. So sometimes people like to say that the ln and the e cancel, so they draw a line through it, and then their answer is the 3/4. The reason they draw that line is really because it becomes a 1, and then 1 times 3/4 is going to be 3/4. Okay, here we have exponents. So first we can get rid of these exponents by applying the power rule. So we're going to take those exponents to the front. So we have 4 natural log of e plus 8 natural log of e. And then we can simplify. Natural log of e is the same as 1. So we're going to end up with 4 times 1 and 8 times 1. So 4 plus 8 is going to be 12. Okay, let's try this one. So here we can apply the product rule first. Notice that z is being multiplied to z minus 1 to the 4th power. Since they're being multiplied, we can separate it as addition. So we have natural log of z plus natural log of z minus 1 to the 4th power. Now I can take my exponent to the front. And so I'm going to end up with natural log of z plus 4 times natural log of z minus 1. Here we have two expressions, they're being divided. So we can separate it using the quotient rule. The quotient rule tells us that if you're dividing, we can separate with subtraction. So we're going to have log 5 square root of x squared minus 9 minus log 5 of 4. Now the square root, we can write it as an exponent of a half. And now I can apply the power rule, which means that I'm going to take my exponent of a half and bring it to the front. So I'm going to end up with 1/2 log 5 x squared minus 9 minus log 5 4. Now inside of the parentheses here, we have x squared minus 9, and that's a perfect square. We can rewrite it as x minus 3 times x plus 3. And now I have two things that are being multiplied in here. So I can separate it with addition using the product rule. So that's going to be x minus 3. So we have the 1/2 times x minus 3 plus the 1/2 x plus 3. So from here, notice that they're being multiplied, so we can separate with addition. Okay, let's try these two problems. So in the instructions, it says to expand. So expand means that your answer is going to have more than one log in it. And so here we're dividing. So we're going to apply the quotient rule. So division says I can separate them as subtraction. So I end up with log base 8 of x minus 3, x to the 3rd power, minus log base 8 of y cubed times z to the 4th. And now let's evaluate each of the pieces here. So we can work on this one here. Notice that y cubed and z to the 4th are being multiplied. So we can apply the product rule. So multiplication means to separate as addition. I'm going to use parentheses here because the minus sign is going to be applied to everything on the right side. So we're going to have log base 8 of y cubed plus log 8 z to the 4th. Again, the addition comes from the product rule since they're being multiplied. Now let's distribute that negative into the parentheses. And we end up with minus log 8 y cubed minus log base 8 z to the 4th. And then the last thing is, do we have any exponents? So we do have exponents, so we want to apply the power rule, which tells us that we can take the exponents to the front. So we're going to have 3 log 8 of x minus 3 log base 8 of y minus 4 log 8 base of z. So you might be asking yourself, why do I need to use these properties? So our whole goal is going to be to solve the equations, and these properties are going to help us to do that, okay? And you'll see them in a little bit. So let's try this one. So this one looks really crazy, right? But everything is under the square root of 10. So the 10th root. So what we want to do first is change that 10th root into an exponent. So my exponent is going to be 1/10. Okay, so remember your index here tells you what the denominator is. So now let's see what's happening in the parentheses. So in the parentheses, we have x to the 7th being multiplied to x fifth plus 7. So we can apply the product rule, or I guess we can let's take care of the exponent first. So let's move that exponent to the front, and now let's apply the product rule. So here we're going to have natural log of x to the 7th plus natural log of x to the 5th plus 7. And then we have this 1/10 that we can distribute into the parentheses. And we're going to end up with 1/10 natural log of x to the 7th plus 1/10 natural log of x to the 5th plus 7. And that would be your expanded form. Notice that you had one natural log, now you have more than one natural log. Okay, so now it says to condense. So condense means that instead of having multiple logs, we just want to have one log. So we're kind of working reverse. So here we're subtracting two items, but before we can do any combinations, we want to make sure that the numbers in front of the logs are 1. If it's not a 1, then we need to take care of that number. So in this case, 9 is not 1. So 9, we need to get rid of that 9. So if we think about where it might have came from, if it's in front of the log, that means that it used to be an exponent. So we're going to make it be an exponent again. Okay. So we would end up with, if I make the 9 an exponent, then I get x to the 9th. Okay, so now we're going to apply the quotient rule. So these are being subtracted. So we can apply the quotient rule, which means that we're going to have 1 log 6 of 3x divided by x to the 9th. If you're able to simplify, then we'll go ahead and simplify. So one of these x's will cancel with 1 on the denominator, leaving us with 3 divided by x to the 8th. Okay, let's try these. So here we have 3 logs, but I don't have no parentheses or anything. So if you don't see any parentheses, we can start from the left side. But first, make sure that the numbers in front are going to be 1. And if it's not a 1, you want to take it to become an exponent first. So first, let's make those exponents. So we get log x minus log y to the 6th power plus log z to the 7th power. Now let's focus on the first two. So we have log x minus log y6. Since they're being subtracted, we're going to apply the quotient rule, and we're going to combine them as log x divided by y to the 6. Now we have log x divided by y to the 6 plus log z7. Since we're adding, then what does that tell us to do? Apply the product rule, which means that we're going to combine them with multiplication. So we're going to have x divided by y6 times z to the 7th. And if we simplify, then we get x times z to the 7th divided by y to the 6th. Okay, let's try letter B. Now in this problem, we do have brackets involved. So you want to work whatever's in brackets first or in parentheses. So here we're adding. So that means we can use the product rule to combine them, and they're going to combine as multiplication. Okay, now we can simplify inside. So if we multiply it out and simplify, then we get x squared minus 1. Now they're being divided. They're being subtracted. So we're going to combine them using the quotient rule, which tells us to divide. So we're going to have natural log of x divided by x squared minus 1. Okay, so those are using your product, quotient, and power rules. Now the main focus of chapter 3 is for us to be able to solve for our equations, to solve for the variables, in this case x. So when we're looking at these problems, if you notice, the first one is already in exponential form. And so you want to always ask yourself, could I use the one-to-one property? Because if you can use the one-to-one property, it makes things a little bit easier. Well, 4 and 2 are not the same, but the next question should be, can I rewrite 4 to have a base of 2? And the answer here is yes, we can write 4 as 2 squared. Now that the bases are the same, then we can set the exponents equal to each other using the one-to-one property. So we get x is equal to 2. Okay. Now for letter B, you have, instead of an exponential function, we have a log function. So in the log function, you can also apply the one-to-one property. And the one-to-one property for log functions means, let me just use my pen really quick so I can show you what the log to the one-to-one property is. Oh, sorry. Okay. I thought I left the chat. Give me a second. Okay, so for logs, we have, if you have the log on one side and you have another log on the other with the same base, so in this example, my bases are A, then the one-to-one property allows us to set B equal to C. Okay, so that's a one-to-one property for logs. So when you're doing these, if you see here, I have natural log of x minus natural log of 13. You want to ask yourself, well, they both have the same base, so that's a good thing. But now I need one to be on the other side. So I'm going to add natural log of 13 on both sides. Okay, so I get natural log of x is equal to natural log of 13. Since the base is the same, then I can use the one-to-one property, and my answer would be x equals 13. Now for logarithms, we have to be careful with our answers because the domain of logarithms is from 0 to infinity. And so whatever answer you get here, you want to make sure that if you were to plug it in for this x, whatever number is in here has to be greater than 0. So if I plug in 13 here, then that is greater than 0, so we're good. So this would be our answer. Now the third one, e to the x is equal to 13. This 13, there's no way that I can ever make it have a base of e. So what we're going to do is, one way to solve for this is multiplying natural log on both sides. And so I'm going to multiply natural log on both sides. And the reason I'm multiplying by natural log is because this is base e and the natural log is base e. So what we can do next is we can see that we have an exponent. So we can use the power rule and take that x to the front. So if I take this x to the front, then I get x is equal to natural log of 13. Let me just show you here really quick because I skipped a step here. So we had natural log of e to the x. So what we can do here is we can move the x to the front, natural log of e, okay? Well, natural log of e is just the same as 1 times x, so we get x, okay? So a lot of times students like to do this, and then they put the x here, and that's their answer. I mean, they don't really cancel. The reason you can do that is because of this right here, okay? But if you want to do that, then that's fine too. So we get x is equal to natural log of 13. If the answer if the question is asking to write an exact form, an exact answer, then this would be your answer here, natural log of 13. But if it asks you to round, then you can use your calculator. Remember, natural log key is in your calculator, so you would enter natural log of 13. Okay, so here we have a few more examples. So it says solve the exponential algebraically. I guess it should say solve the exponential equation algebraically, and then approximate your answer to 3 decimals. Okay, so one of the things to recognize here is that your equation is already in exponential form. What is the base on the left side? The base is e, and on the right side, my base is also e. So that's a good thing because the base is the same. So I can use the one-to-one property. And the one-to-one property says if these are the same, then we can set the exponents equal to each other. So my exponent here is x, and then I have x squared minus 6. Now what's left here is an equation that's quadratic. Well, in order to solve quadratic equations, everything has to be on the same side. So I'm going to go ahead and do that. So we can subtract x on both sides, and then we end up with x squared minus x minus 6. Now we have choices, right? So what we can do now is you can either try to factor or you can use a quadratic formula. Remember, not everything factors. So if you give yourself a minute and you can't come up with the factors, then it might not be factorable. So using the quadratic formula will provide you that answer. But in this example, it does factor. So we get 0 is equal to x minus 3 times x plus 2. So we end up with 0 is equal to x minus 3 and 0 is equal to x plus 2. Solve for x. So my answer is x equals 3 and x equals negative 2. Okay, so now let's look at these. These are also exponential. Well, in order to solve for these exponentials, we want to leave the exponential part, which is this 3 to the x by itself. So first, we're going to divide by 5. So we end up with 3x, 20 divided by 5 is 4. Now I can ask myself, can I use the one-to-one property? And there's no way because 3 and 4, we can never make them the same. So we can use logarithmic properties. So we're going to multiply on both sides by natural logarithmic properties. So we're going to multiply on both sides by natural log. And now I have this x here. So I can use the power rule and bring the x to the front. And so now I have x of natural log of 3 is equal to natural log of 4. We're trying to solve for for x. So I can divide by natural log of 3 on both sides. And that's going to give me x is equal to natural log of 4 divided by natural log of 3. So that would be your exact answer. If you need a decimal, then we can enter it in the calculator. And if you can see, this is how I would enter it in my calculator. Any questions on that one? Okay, so on this one, always leave the exponential part by itself. So we need to get rid of the 9. So I can add 9 on both sides. And I get e to the x is equal to 27. Now I can multiply on both sides by natural log. And so the natural log and the e are going to become 1. But if you apply the power rule, then this x goes to the front. And so we just end up, excuse me, we just end up with x equals natural log of 27. And then that's your exact answer. In decimal, it would be approximately 3.807. All right, so now all of those were exponentials. Now let's look at the logarithms. So I have natural log of x is equal to negative 4. So if we're trying to solve for x, the problem here is that x is kind of trapped with this natural log. So what we want to do is we can change it to exponential form, okay? So natural log, remember, is the same as log e. And then if I want to change this to exponential, the base is e. The log is always equal to the exponent. So this log is equal to -4. So that's going to be your exponent. And so then we can use our calculator and enter e to the -4, which came out to 0.018. Okay, so anytime you see natural log, you can write it as log e. Now, one of the things I see students make mistakes on the WebAssign is when they're trying to enter natural log on the computer, instead of LN, they enter IN. So make sure that you're using an L instead of an I for LN. Okay. So let's look at this one. We have 2.8 equals natural log of 3 times x. So here we're going to change it to exponential form again. So again, natural log is the same as log e. So your base is e. The log is equal to the exponent. So we get e to the 2.8 is equal to 3x. So now we can divide by 3. So we get x is equal to e to the 2.8 divided by 3. In your calculator, I would have 5.418. So on the next one, we're going to subtract 5 first so that we can leave that natural log by itself. And so we end up with -5 natural of x equals 6. We can divide by -5 on both sides. And now we have x over here by itself. So we're going to change natural log to exponential. So we get log of base e of x. So e is our base. This log is equal to -6/5. So that's going to be our exponent. And then we have x. You can't see the negative, but it is right there. And if we enter that in our calculator, we get 0.301. All right, so the next one is getting more and more logs in there, right? So here we were on the previous page, we were able to do this process because we only had one log on one side. So here, maybe we should move one of the logs over, or we can use properties to make it into one log. Since they're being subtracted, then I can use the quotient rule and divide them. So I'm going to have natural log of x divided by x plus 6. Then I'm going to convert it to a exponential form. So remember, natural log is log e. So my base is e. The log is equal to 7. So that means 7x your exponent. And now x is in a place where I can solve for x. So I'm going to multiply by x plus 6 on both sides. And I end up with this. And I need to somehow combine this, right? So I'm going to multiply e to the 7 into the parentheses. So I get e to the 7x plus e to the 7 times 6. And I'm going to put all my x's on one side. So let's put all the x's on the left side. So I'm going to subtract the x. And I'm going to subtract e7 times 6 to the right. And now notice that they have an x in common here. So I can factor out an x. And I end up with x times e to the 7 minus 1. And since I'm trying to solve for x, I'm going to divide by e to the 7th minus 1 on both sides. And then I'm going to enter that in my calculator. So in my calculator, what I did first is I entered negative e to the 7th times 6. Whatever answer I got here, I just click answer divided by my denominator. So be careful on how you enter it in the calculator, because some calculators are not smart and they need a little help with parentheses. And I also encourage you, if you do this first, don't round this answer until the very end, because if you round before the very end, then it's going to count your answer incorrect. Now, for any answers that you get when you're solving for these logarithms, you have to make sure that your answer is a solution. Since I got that x is negative 6.005, what you want to do is you want to go back to the original problem, and if you substitute it in for x, whatever x is here has to be positive. Well, if I put in negative 6.005, then this part here is no longer in our domain, so we cannot use this as a solution. So in reality, even though you solved for an answer, you got an answer, it's not a solution because this is going to be negative. Okay, let's try the next one. So here, let's combine the right side by using the quotient rule. So we get x minus 6 divided by x plus 6. And now notice that on the left side, I have a base e, and on the right side, I have base e. So I can set those equal to each other. So I end up with x plus 9 is equal to x minus 6 divided by x plus 6. So we're going to multiply on both sides. And let's simplify. So we get x squared plus 6x plus 9x plus 54 equals to x minus 6. This is quadratic, so everything has to be on the same side. So let's take the x and 6. So let's take the x and 6 to the left side, and we end up with x squared plus 14x plus 60. So at this point, you can factor or use a quadratic formula. So if I try to use the quadratic formula, then notice I end up with a negative in the square root. That means that our solution is imaginary, and so we have no solution. Okay, one more here. We have log 9x minus log 9x minus 8 equals a half. So we can combine those using the quotient rule. So since they're being subtracted, we're going to divide. And then we're going to change to exponential. So my base is 9. The log is equal to a half, so half is your exponent. So 9 raised to the half power is the same as square root of 9. So we get a 3 plus or minus 3, and we're going to solve for x. So if we multiply by x minus 8 on the left side, we get 3 times x minus 8 equals x. 3x minus 24 equals x. Subtract the x, so we get 2x. So one possible answer is x equals 12. And on the right side, notice I use the negative because we get plus or minus 3. On the right side, we end up with x equals 6. So these are possible answers. Now we got to check if they are really solutions. So the first one, x equals 12. If we plug in 12 for x, we get log 9 of 12. So that's okay because this is the part in red is greater than 0. And if I plug in 12 here, I get 12 minus 8, which is 4, and that's okay. So now let's look at 6. 6 is okay here, but when we enter it here, we get 6 minus 8, and we end up with a negative 2. Therefore, the only solution is x equals 12, and x equals 6 is not a solution. So that was the last example. If you have any questions, you can ask us. But I want to wish everybody the best of luck. I know some of you have your exam due. If taking my online class, it's due on, I think, Monday. And then if it's a face-to-face class, some of you are taking the test next week. And so whenever your test is, we wish you the best. And if you have any questions, let us know. And they did put the some links to the YouTube channel, so you can always go back and view the presentation again if you felt that I went too fast, or maybe you wanted to see the example again. But I'll pass it over to our staff, and we'll see you next week.
Thank you, Ms. Chuka, for your wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on the YouTube playlist. Today's session will also be available on the playlist later on today. Also linked is a short survey to help us improve our TVE sessions. Please take time to fill out our survey. Before you all leave, I want to share the TVE sessions we will have next. We'll be back next week with Happy Math Hour, which it starts at 11. This is a reminder. For Math 1314, for next week, we'll be covering the linear and nonlinear systems. And then Math 1324 will be covering Exam 3 review. For next week's Student Success, we'll be presenting the Gardening Club with Mr. Isasi. At 1 p.m. today, we would like to have you return, if possible, to join us with the Student Success, and they'll be presenting nursing program and the resource. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use the chat box or mic. We hope to see everyone again for Math Happy Math Hour.